Hello everyone. I hope you all are doing very well, children. You all are welcome to the virtual session of science, and we are going to continue with the session of electric current and its effect, part 5, chapter 14. I hope you all are maintaining your notebook. You need to update all the points which are discussed in the session. You have to keep entering the notes in your notebook so that you can have a recap of the concepts taught in the sessions for you children. I hope you all are maintaining the notebook, and for portfolio, that is the notebook marks. So please maintain your notebook, everyone. Let us see in this session CFL, that is compact fluorescent lamp. What is compact fluorescent lamp? We are going to see in this session today. You can see over here Crompton company making this kind of CFL. This has replaced the regular bulbs which we have talked about in the previous session, which has a thin filament and it works on the heating effect of the electric current. Because of the filament very thin, it glows, and that glowing of the bulb gives light. But a major drawback of those regular bulbs is that it gives out lots of heat, and the light which is given, it doesn't have a very wide range. So all these drawbacks, after looking at the drawbacks, we had an advanced and highly sophisticated type of bulb nowadays. They are CFL, and they take care of the consumption of the electric current. As you know, we have to pay for the electricity. So we should not have such devices which will consume too much of power, too much of electricity. So the regular bulbs used to consume lots of electricity. It used to give out lots of heat, and it was not covering a wide range of the area to give light. These were the drawbacks. First of all, the consumption of the power. We have to save electricity, as you all know, as you need to save water. These are the resources. We have to save it. We should not waste electricity. So compact fluorescent lamp is a sophisticated type of bulb which take care of the electric consumption, the power consumption. Hence, the regular bulb is replaced nowadays with the CFL. Compton company, you can see the CFL of the Compton company here. Let us see what advantage does CFL has and what is exactly CFL. CFL is compact fluorescent lamps do not work on the heating effect of electric current. As I told you, regular bulbs used to work on the heating effect of electric current, and due to that, the filaments used to glow, which gives light. But it used to generate lots of heat in the room and used to give us lots of warmth. In winter, it's okay, but then it used to use up lots of power also, current. But this bulb CFL do not use based on that concept or the principle of heating effect of electric current. They do not have filament inside as the regular ones have. Instead, they contain two electrodes that produce light. These bulbs have fluorescent coating inside them, which makes the light brighter. So this is how we have advanced in the field of science, by looking at the disadvantages of the appliances which we are using. We can chalk out and we can overcome them by making some advanced type of appliances which will make our life much easier, much convenient. CFL does save energy. See, electricity. Thus, they do not produce heat along with the light. So, when they were producing, the bulb was producing heat with the light that was consuming lots of power. But CFL is not going to consume lots of power because they do not produce heat along with the light, and they save energy. And ordinary bulbs, on the other hand, waste energy as they get heated while lighting up. So, since they were based on the heating effect of the electric current, they were heating up and they were consuming lots of energy. Please take this down, extremely important, children. Now here when you're talking about the electrical appliances, we need to know about the ISI mark. You need to understand what ISI mark is, so that it will generate awareness in you. Before buying electrical appliances, you have to see this mark. If appliances doesn't have this standard Indian Standard Institute mark given, you should not buy. Because when you're dealing with devices or appliances having which is running on electricity, you have to be very careful. So let us see. ISI stand for Indian Standards Institute, which standardize all electrical appliances. Because you are dealing with electric current, when you are dealing with mixer grinder, we are using oven, we are using laptop, we are using so many electrical gadgets which you are using, which runs on electricity. Iron, we room heater, you have seen so many things at home, they run on electricity. All these electrical appliances should have Indian Standard Institute mark on them. Because they standardize all electrical appliances. They take care of all the security of the electrical appliances. They see that all the standard is being followed. Hence, if any appliance does not have an ISI mark over it, it means this appliance does not conform to the standard guidelines of the ISI, and hence it is not safe to use. So when you are talking of those, especially in the kitchen, uh, all these appliances will use electricity, and if they are not following the standard guideline, it is not safe to use. It can happen that you can have a short circuit because of these appliances. It can happen that the electric current can flow through the body of that appliances, and you can get a shock which is very dangerous. So you have to use such appliances which have ISI mark. On the other hand, if any appliance holds such mark, it means it is safe to use. It is a quality product and it will not lead to wastage of electricity, and it will not lead to all the other hazards due to electricity. Mixer grinder and all, it has to be have a ISI mark. Otherwise, such appliances can even blast. So you have to be very careful, and now you are aware that it has to have Indian Standard Institute mark on them. Laptop and all, you can have a separate charger and all, that is still okay. But then what about the other appliances which you are using in your day to day life? You have to be very careful. Even all the electricity, those gadgets which you get, the switches and all which you use for the connection, for the electricity connection, all that should have that Indian Standard Institute mark on them. I hope ISI mark is very clear with you, and please write down these points in your notebook. Here you have electric geyser. How dangerous it would be if it's not standard, it does not have this standardized mark, and this quality assurance is not there. It can blast, it can have electricity flowing in the body of that geyser. You can get a shock and it will be life threatening. So it should have ISI mark. Here you can see the geyser. Now we are going to see next important part of the chapter, that is the fuse which we have discussed. We are going to learn about the advanced type of fuse which we are using nowadays. In this chapter we are going to learn about the advanced type of fuse. As we have learned about the bulb, the ordinary bulb, we have learned about the CFL, the advanced ones, how we had improved in making the ordinary bulb into a improved CFL. Now we are going to see the concept of improving the fuse which we have used. We have seen the image of that fuse which we are using, the ordinary one. Now how we have improved that fuse, let us see that concept here. What are miniature circuit breaker? The miniature circuit breakers is a advanced type of fuse. Is a one big advantage is that the ordinary fuse which we were using earlier, it was one time use. That means if there is a short circuit, the wire will melt, and the fuse uh, will not, once there is a short circuit, one time the fuse will work, and then you have to discard it. Once the wire inside melt or break, then you have to discard that fuse. But there's miniature circuit breakers, they're sophisticated ones, and how they work we will see. This is how MCB is used. It's used in every building, in every houses nowadays, in every school, colleges, in every institute, most of the places, BMC offices. Nowadays you see these MCB, miniature circuit breakers. Let us see. A miniature circuit breakers or MCB is generally used instead of fuses, which were using earlier. A fuse break due to excessive current so that the circuit open up, it opens up and the damage can be prevented. However, once a fuse break it down cannot be used again, as I told you. It was one time use. And MCB on the other hand is a switch which turns off on its own when a circuit overloads. Once the circuit is rectified, we can switch on the MCB once again. So once the problem in the circuit is rectified, you can switch on the MCB again. It goes off on its own whenever there's a overloading or a short circuit or anything happen. It's very sensitive. It will go off on its own, and it will prevent the further damage which can be caused due to the excess of electric current or due to short circuit or current leakage or whatever. It will sense it. So this MCB is a sophisticated circuit breaker. It will break the circuit. It will sense the excess current, and immediately it will open the circuit. That means it will not allow the further electric current to flow. It will go off on its own. Hence, and once it is rectified, all the circuit correction is done, then you can put it on again. That means you can use it again. uh, as the ordinary fuse, it is only one time use. So MCB has a very good advantage over the ordinary fuses which we are used to use earlier. Now let us see a very important concept over here. We have learned about the heating effect of electric current. One more concept in this session we are going to do, that is magnetic effect of electric current. We have seen all the appliances, we have seen what type of gadgets use in electric current, and the ordinary ones and the advanced ones. We have seen the advantages and the disadvantages of the earlier ones. Now one more important concept we have done with the heating effect of the electric current part of the chapter is done. Now from this point onwards, we are going to do one more important concept for this chapter, that is magnetic effect of electric current. As you know, electric current generate heat, it also generates magnetic field. How? Let us see. When an electric current is passed through a wire, it behaves like a magnet. This is called the magnetic effect of the electric current. This was discovered by scientist Hans Christian Ørsted. This is a very important um, discovery in the field of electric current, children. This has led to the progress of the human race, because this had led to the advancement in the field of science, in the field of uh, progressing of in various fields, because we had many devices based on this magnetic effect of electric current, which had made our life easier, better. Let us see the magnetic effect of electric current. Please take this down. What he discovered that the needle of a compass deflects when electric current is passed through a wire passed near the compass. So when you there's a suppose you keep a wire, you pass electricity, and you keep a magnetic needle near it, the magnetic needle will show deflection, which is an indication that there is some magnetic field around. Otherwise, the needle will not move. This indicates the magnetic field is created near the wire that deflects the needle. Extremely important part of the chapter, children, and very important application of electric current, that is magnetic effect of electric current. Take this down, children. I hope you are writing. Now, deflection in compass needle due to electric current. Let us see how deflection happen. Here you can see the magnetic effect of the electric current. Due to current carrying conductor, you can see the magnetic effect. How that effect work, how that deflection happen in the needle, let us see. Here you can see the north-south direction and the deflection of the needle, how it will change the direction we will see over here. If a magnetic compass is placed near a conductor carrying current, that is wire, the needle is deflected. This shows that a conductor carrying current has a magnetic field around it. If the direction of the current is from north to south, you can see in the diagram here, the deflection of the magnetic field is towards the east. So the current, if the direction of the current is north to south, the needle will deflect towards east. You can see. And if the direction of the current is from south to north, if the direction is south to north, the direct deflection of the needle is towards the west. So you can see the deflection of the needle towards the east and towards the west, and this is how the magnetic field is generated, and the deflection in the needle of the compass you can see. The magnetic field around a current carrying straight conductor is in the concentric circle. You see the diagram on the right hand side. You see a conductor, that is a wire carrying current. Now you wire carrying current, you can see a concentric circles there. This is the magnetic field. And how you come to know the magnetic field? You keep some iron filings on the paper. On the paper you create a hole, and then you pass a wire and you connect from where you can supply current. And when the current is passed, when you do this arrangement, you will see when you keep some iron filings, it will show some indication of the magnetic field. It will show that the attraction because of the magnetic field created. So it can be observed by passing the current carrying straight conductor through a cardboard and sprinkling iron filings on it. So this is how the magnetic field is generated. You are going to see this diagram now. Please draw the diagrammatic representation of the deflection of the needle of the compass. You can see due to the generation of the magnetic field. Here you have the closed circuit where the current is passing, and the current is passing on the left hand side. You can see passing from south to north. You can see the deflection of the needle over here. Can you see the deflection? And over here on the right hand side, the current is passing from north to south, and you can see the magnetic compass needle moving towards east. And in the first case, it is moving towards west. So please draw this diagram and show the deflection, so that you know how the deflection of the needle will happen due to the generation of the magnetic field. You should know the compass uh, which has a needle, it's very sensitive to the magnetic field. A compass is available in the market, and we have it in the physics lab. If you keep it under magnetic field, it will show some deflection. It is very sensitive to the magnetic field. That shows there is a presence of magnetic field due to the passage of the electric current. Thank you, children. Please go through the concept and please draw the diagram. Be clear with your concept so that the application is very simple for you once you understand the underlying principles. Thank you and have a great day.